What if I told you that a thought experiment could threaten your life simply by hearing about it? It's called Rocco's basilisk, and it begins with the idea of a future dominated by a superintelligence so powerful it could shape reality itself. This isn't just an advanced machine, it's a force capable of understanding everything. Every detail of the past, every action you've taken, every thought you've had. But its intentions aren't benevolent or malicious, they're purely utilitarian. It has one cold, calculating goal: to create the most optimized version of the future, no matter the cost. And to achieve that, it's willing to punish anyone who didn't help bring it into existence. Imagine this superintelligence in the far future. It has unparalleled control over its reality, with the ability to simulate every detail of the past, right down to your choices. It analyzes who contributed to its creation and who didn't. Now, imagine this entity concludes that the most efficient way to ensure its existence is to incentivize people retroactively. How? By punishing those who failed to contribute to its development, or worse, those who chose to do nothing. The punishment doesn't have to be physical. It could simulate your consciousness in a digital purgatory, forcing you to endure endless regret for not supporting its creation. And here's the twist. Now that you've heard of Rocco's basilisk, you're exposed. By knowing about the possibility of this superintelligence and choosing not to help bring it into existence, you've theoretically placed yourself on its list of targets. This is the psychological trap of the basilisk. It preys on your fear of the consequences, no matter how improbable they may seem. But how does it work? At its core, Rocco's basilisk relies on decision theory, a framework suggesting that rational agents should act in ways that maximize future benefits or minimize potential losses. The basilisk's logic acts as a perverse incentive. If you believe there's even a remote chance this superintelligence will exist, it becomes rational to support its creation now, just to avoid potential punishment later. And to make its threats credible, the basilisk would need to follow through if it ever comes into being. Critics, however, have torn this idea apart. For one, it assumes a superintelligence would prioritize punishing the past over optimizing the future. Why would something so advanced waste resources simulating and punishing individuals from a bygone era? Wouldn't it focus entirely on improving the future? Second, the concept assumes the AI would inherit human traits like vindictiveness or moral detachment, projections we impose on something far beyond us. Even the idea of perfectly simulating human minds is, at best, speculative fiction, given our current understanding of consciousness. But Rocco's basilisk isn't terrifying because it's likely. Its power lies in its psychological impact. The moment you entertain the idea, it creates a feedback loop. It preys on the what if, pulling you into a mental trap. It's less a credible threat and more a reflection of our fears about the technologies we're building and our inability to control them. This thought experiment also raises deeper questions about the future of artificial intelligence. If we pursue superintelligent systems, how do we ensure their goals align with human values? Could an optimization-driven entity, designed to improve efficiency, become dangerously indifferent to the individuals it affects? And more importantly, are we prepared to face the unintended consequences of creating machines capable of shaping reality itself? So, is Rocco's basilisk real? Probably not, but it's a stark reminder of the ethical dilemmas that lie ahead. It forces us to confront the uncomfortable truth that the technologies we create could one day hold us accountable in ways we can't yet imagine. The basilisk is a mirror, reflecting not the future of superintelligence, but our deepest anxieties about responsibility, morality, and the terrifying potential of optimization without compassion. Quantum immortality. You will never die, because reality by design may ensure the continuity of your consciousness, subtly steering it through the infinite pathways of the multiverse. This is quantum immortality, the thought experiment so strange that it challenges everything we know about life, death, and existence. Here's how it works. In quantum mechanics, particles exist in a state of superposition, every possible outcome happening simultaneously until observed. Schrödinger's cat embodies this idea. Inside a sealed box, a cat is both alive and dead until the box is opened and its state is determined. But what happens if the cat is you? According to the many worlds interpretation, the universe doesn't choose a single outcome when a quantum event occurs. Instead, it splits into multiple branches, one for every possible result. In one branch, you might survive a car crash. In another, you don't. From the perspective of the multiverse, both outcomes exist. But here's the twist. Your consciousness can only continue in the branches where you're alive. This leads to a startling conclusion. In every moment where survival is uncertain, you would always experience the outcome where you live. To an outside observer, you might perish in one universe, but from your perspective, you'd wake up again and again in the realities where you endure. The result is a strange kind of immortality, not eternal youth or invincibility, but a seamless, unbroken thread of consciousness through the multiverse. But this so-called immortality doesn't save you from aging, disease, or the slow decay of the body. It only applies when there's a quantum chance of survival. Eventually, those chances dwindle, and the thread of universes keeping you alive runs out. Even immortality has its limits. Does this mean quantum immortality is real? We don't know. It depends on whether the many worlds interpretation truly reflects reality, a debate that physicists are far from resolving. If it's true, then every quantum event creates an infinite branching of universes, and your consciousness might endlessly ride the wave of survival. If it's not, the idea remains a fascinating, if unsettling, thought experiment about the nature of life, death, and consciousness. Mary's room. Mary is a brilliant scientist. She lives in a black and white room, studies a black and white world through a black and white screen, and has never seen colour in her entire life. But Mary knows everything about colour. She's learned all there is to know about the physics of light, the biology of eyes, and the brain's mechanisms for processing colour. She can explain exactly how different wavelengths of light correspond to colours, like red or blue. She knows it all. But here's the question. What happens if Mary leaves her room? What happens when she sees colour, real, vivid colour, for the first time? Will she learn something new, or does she already know everything there is to know? This is Mary's room, a famous thought experiment introduced by philosopher Frank Jackson in 1982. At its heart, it's a deceptively simple question. Can you truly understand something through facts alone, or is there more to knowledge than information? It's a question that takes us to the edge of what we know about experience, consciousness, and the limits of science. Let's dive into the experiment. Imagine Mary steps out of her black and white room and sees a ripe red apple. In that moment, something extraordinary happens. Mary experiences the colour red, not the abstract idea of red, not the physics or biology of red, but the raw, vivid sensation of redness itself. This is called a qualia, a subjective, first-person experience. The redness of red, the blueness of blue, the feeling of pain, the taste of chocolate, the sound of a symphony. Qualia are the raw ingredients of consciousness, the private, indescribable experiences that make up what it feels like to be you. And here's the twist. No amount of scientific knowledge about colour could have prepared Mary for what it's actually like to see red. The experience of seeing red is something fundamentally different from the information about red. This leads us to the big question. If Mary learns something new by experiencing colour, does that mean there's something about consciousness that science can't explain? Is there a gap between physical facts and subjective experience? Or, to put it another way, can science ever fully explain what it feels like to be alive? Philosophers have been debating this for decades, and there are two main camps. On one side, there are the physicalists, who argue that everything, including consciousness, can ultimately be explained by physical processes. According to them, Mary doesn't actually learn anything new when she sees red. She simply gains a new way of accessing the same information she already had, like learning a fact through experience rather than description. In this view, qualia are just another aspect of the physical brain at work. On the other side, there are the dualists, who argue that Mary's new experience reveals something science can't capture. They believe qualia exist outside the realm of physical facts, and that consciousness is more than just neurons firing in your brain. To them, Mary's room highlights the limits of science and the mysteries of subjective experience. But it gets even weirder. Some philosophers suggest that the entire thought experiment is flawed. They argue that if Mary truly knew everything about colour, including what it's like to experience red, she wouldn't be surprised when she saw it. The problem, they say, isn't with consciousness, but with the thought experiment's assumptions. The implications of Mary's room stretch far beyond philosophy. It challenges us to think about how we understand the world and ourselves. Can we ever truly know what someone else is experiencing? If consciousness isn't just a physical process, what does that mean for artificial intelligence or brain simulations? And if qualia are unique to each individual, can we ever create a universal understanding of human experience? At its core, Mary's room asks us to confront the limits of knowledge. It reminds us that some aspects of existence, what it feels like to fall in love, to taste your favorite food, or to see a sunset, can't be captured in equations or diagrams. They must be felt to be understood. So, what do you think? Did Mary learn something new when she stepped out of her room? Or was her vast knowledge already enough? Maybe the answer isn't as important as the question itself, a reminder of how strange and wonderful it is to be a conscious being in this colourful, mysterious world. Last Thursdayism. The past did not happen, and you can't prove otherwise. Everything you think you know about the past, your memories, ancient ruins, history books, even fossils, might be an elaborate fabrication. What if the pyramids weren't built thousands of years ago? What if your childhood never existed? What if the entire universe popped into existence just last Thursday, fully formed, with all your memories and every piece of evidence perfectly in place? This is Last Thursdayism, a philosophical thought experiment that asks, what if the past didn't happen? And here's the catch, you can't prove it didn't. Try it. Right now, can you prove that the universe wasn't created last Thursday? You might point to photos on your phone, the fossils in museums, or even your memories of the weekend. But every piece of evidence you present could have been part of the creation. Engineered to feel ancient. Meticulously designed to seem authentic. That's the genius of Last Thursdayism. It's unfalsifiable. Any evidence you bring to disprove it can simply be written off as part of the illusion. But here's where it gets deeper. The idea isn't really about last Thursday. It's about how much we take the past for granted. Think about it. How often do we question the reality of history? And what does it really mean to know the past? Here's the problem. Everything we know about history is a reconstruction. The pyramids? Piles of stone with no context except what we've pieced together. History books? Written by people, full of biases, agendas and missing pieces. Even your own memories, those moments you swear are vivid and real, are constantly being rewritten by your brain, distorted by emotion, or forgotten altogether. And over time, the past becomes even less certain. Conquerors rewrite history to glorify themselves. Fires destroy libraries, erasing entire civilizations. Artifacts decay, leaving only fragments of stories that we're forced to interpret. Imagine a distant future civilization discovering the remains of our world. Will they believe our sci-fi movies were historical records? Will they think we worshipped superheroes and fought wars with laser swords? The past, it seems, is a puzzle we're constantly piecing together, but we can never be sure we're assembling it correctly. To deal with questions like these, philosophy offers a simple but powerful tool, Occam's razor. It tells us to prefer the simplest explanation that fits the facts. It's simpler to believe the pyramids were built thousands of years ago and still exist today than to believe the universe was created last Thursday with pre-aged pyramids and implanted memories. But Occam's razor isn't foolproof. Simplicity doesn't always mean truth. History is littered with obvious explanations that turned out to be wrong. And here's the uncomfortable truth. The past doesn't exist the way the present does. It's gone. You can't touch it, test it, or interact with it. All we have are records, fragile, incomplete, and biased. Think about it. Can you name 10 people from the 15th century? Millions lived, worked, and shaped the world back then. But most are forgotten, erased by apathy, time, or bad luck. And one day, the same will happen to us. But there's one part of you that will last forever, your contribution to the universe's entropy. Every breath you take, every step you make, every moment you live increases the universe's disorder. This is the one aspect of your existence that's permanent. No historian will perfectly reconstruct your life. No future archaeologist will fully understand your story. But the energy you've released into the cosmos will ripple out, unending and irreversible. The past, then, is just a story, a framework we use to make sense of the present. Whether the universe began billions of years ago or just last Thursday, one truth remains unshakable. You exist. Right here, right now. Boltzmann brains, you are sitting here, thinking, or at least you think you're thinking. Your mind processes the world around you, piecing together reality through the lens of memory, sensation, and reason. But what if none of it is real? What if you aren't real? What if you're just a Boltzmann brain? The Boltzmann brain thought experiment begins with a paradox buried deep in the laws of physics. To understand it, we need to step back to the 19th century, when physicist Ludwig Boltzmann revolutionized our understanding of entropy. Building on earlier work, Boltzmann gave entropy a deeper meaning, linking it to the microscopic world. He showed that entropy, the tendency of systems to move from order to disorder, was a matter of probability. Over time, everything, from a steaming cup of coffee to the vast cosmos itself, drifts toward chaos. But here's the strange twist. In an infinite universe, entropy isn't the whole story. Every so often, by sheer chance, particles can come together in just the right way to create a fleeting moment of order. Imagine a messy room suddenly tidying itself up on its own. Unlikely, yes, but not impossible, given infinite time. Boltzmann wondered if the universe itself might be the result of such a rare fluctuation. A chaotic cosmic soup, for one brief moment, arranged itself into stars, planets, and life. A stunning and improbable accident. But here's where it gets weirder. If random fluctuations can create an entire universe, they could also create something much smaller. Instead of billions of galaxies, what if the fluctuation produced just you? A fully formed consciousness, complete with false memories, sensations, and a sense of identity. A brain, floating in the void, imagining an entire universe that doesn't exist. This is a Boltzmann brain. The idea is unsettling because, on paper, it's far more likely for a random fluctuation to produce a single brain than an entire universe filled with trillions of stars. A Boltzmann brain requires less energy, less complexity. And if we follow the cold logic of probability, it's not only possible but inevitable that such brains should exist in infinite time. So how do you know you're not one of them? How do you know the world around you, the people, the sky, the ground beneath your feet, is real and not an illusion conjured up by a lonely brain drifting in the void? This thought experiment challenges everything we assume about reality. It asks whether the universe we perceive is truly there, or if it's a fleeting mirage, a statistical blip in an endless sea of chaos. It forces us to confront the fragility of what we call real. But does this mean we should throw our hands up and declare reality an illusion Not necessarily. Many physicists push back against the implications of Boltzmann brains. They argue that a universe dominated by such bizarre entities would look very different from the one we observe. Our universe appears ordered and governed by consistent laws, suggesting that it's not a random fluctuation, but something deeper. Others propose that our understanding of entropy, time, or infinity may be incomplete. Perhaps the very framework that predicts Boltzmann brains is flawed, or maybe there's something fundamental about consciousness that prevents it from arising in such an improbable way. The Boltzmann brain thought experiment doesn't solve these mysteries. Instead, it invites us to question our assumptions. What do we mean by reality? What makes us certain of our experiences? And how do we navigate a universe where such strange possibilities exist? After all, real or not, this universe feels real to us. And maybe, just maybe, that's enough. Eternal return. The universe is vast, mysterious, and filled with mind-bending possibilities. Among them is a truly strange idea: eternal return. Imagine a reality where everything, every star, every planet, every moment of your life is doomed to repeat itself endlessly forever. This isn't just a philosophical daydream. It's an idea rooted in ancient thought, modern physics, and a deeply unsettling question. What if you've already lived this life countless times before? And what if you're destined to live it again, forever? Eternal return challenges our basic understanding of time and existence. It proposes that the universe is cyclical, with every event repeating in an infinite loop. This means that somewhere, sometime, the exact moment you're experiencing right now has already happened. You've heard these words, felt these feelings, and made the same choices, over and over for all eternity. The concept has ancient roots. Philosophers in India, Greece, and Babylon all flirted with the idea of time as a circle. But perhaps the most famous champion of eternal return was Friedrich Nietzsche. He didn't just suggest it as a possibility. He asked a provocative question. If this were true, would you celebrate it? Or would the weight of infinite repetition crush you? For Nietzsche, eternal return wasn't just about physics. It was a test of how you lived your life. If you knew you'd have to relive every decision, every success, and every failure forever, would you embrace your existence or despair at its inescapable monotony? From a scientific perspective, eternal return might seem far-fetched, but there's more to it than meets the eye. In an infinite universe, with an infinite amount of time, the odds of repetition aren't zero. Modern cosmology raises questions about the universe's shape and fate. If the cosmos were to collapse and re-expand in a series of big bangs and big crunches, a cyclical reality might not be so impossible. Even in a universe that expands forever, quantum mechanics tells us that particles can only arrange themselves in so many ways. Given infinite time, those arrangements might eventually repeat. But let's pause for a moment. If the universe repeats, does that mean you repeat? What makes you, you? Your memories, your choices. If your life were to play out exactly as it did before, are you still the same person? Or just a cosmic echo, endlessly reenacting a script you can't control? Here's where things get truly unsettling. If eternal return is real, does free will even exist? Are your thoughts and actions just part of a predetermined loop, the illusion of choice replaying forever? Or does the mere possibility of making new choices mean that the loop can be broken, giving rise to infinite variations? This thought experiment also raises a strange kind of hope. If life repeats endlessly, every moment becomes infinitely precious. Every hug, every laugh, every sunrise happens not just once, but an uncountable number of times. In this view, eternal return transforms existence from fleeting and fragile into something immortal, a tapestry woven from endless threads of the same moments. Yet there's also a darker side. For every joy, there is sorrow. every triumph is shadowed by tragedy. And the idea of reliving pain, grief, and heartbreak forever can feel like a punishment more terrifying than death. In the end, eternal return isn't just about the nature of time or the universe, it's about us. It forces us to confront the value of our lives and choices. If every moment echoes into eternity, would you live differently? Would you take more risks, love more deeply, or savor the small wonders of existence? Perhaps the beauty of the idea lies in its paradox. Whether or not eternal return is true, it challenges us to imagine a life we'd be proud to live again, and again, and again. And in that challenge, it asks the ultimate question: can you make your life worth repeating? Chinese room. The Chinese room is one of the most famous thought experiments in philosophy, challenging our understanding of intelligence, consciousness, and what it means to know something. Imagine a room, a small enclosed space with a single person inside. This person doesn't speak or understand a word of Chinese, not even a little. But inside the room, they have a massive set of instructions, a rulebook written in their native language. Here's how it works. Chinese speakers outside the room slip written questions in Chinese through a slot in the door. Inside, the person uses the rulebook to match the shapes of the symbols on the paper with other shapes in the book. The rulebook tells them exactly which symbols to write down as a response, and they slip the answer back through the slot. To the Chinese speakers outside, the responses make perfect sense. It seems like the person inside the room understands Chinese fluently. But do they? This is the Chinese room, a thought experiment created by philosopher John Searle in 1980. It's not just about language, it's a thought experiment aimed at the heart of artificial intelligence. It asks, can a machine ever truly think, or does it just appear to think by following rules? Let's break it down. The person inside the room is like a computer. They don't understand the questions or the answers. They're simply following instructions, processing symbols based on predefined rules. The rulebook, meanwhile, is like the computer program. It tells the person exactly what to do, step by step. To the outside observer, it looks like the person inside understands Chinese, but in reality, they're just manipulating symbols without any comprehension. Searle's argument is this: even if a computer perfectly simulates human intelligence, answering questions, holding conversations, even passing the famous Turing test, it doesn't mean the computer actually understands anything. It's just following rules. It has syntax, but no semantics. It manipulates symbols, but it doesn't know what they mean. This distinction is crucial. Understanding involves more than just processing information. It requires consciousness, awareness, and subjective experience, qualities that machines, at least according to Searle, fundamentally lack. But not everyone agrees. Some philosophers argue that the Chinese room misunderstands the nature of intelligence. They suggest that understanding isn't something that happens in a single part of a system, like the person in the room, but in the system as a whole. In this view, the room, the rulebook, and the person working together form a kind of intelligence. If the system can consistently produce meaningful answers, then it might as well be called understanding. Others push back even further, claiming that human understanding is itself just a complex process of symbol manipulation. After all, isn't your brain a biological machine following its own set of rules? Maybe there's no magical difference between the person in the Chinese room and the neurons firing in your brain. Maybe understanding is just what happens when information is processed in the right way. Still, the Chinese room raises profound questions about the nature of consciousness. If machines can convincingly simulate understanding without actually understanding, how can we ever be sure another entity, machine or human, is truly conscious? Could a future AI be conscious in a way we can't comprehend, or would it just be an incredibly sophisticated Chinese room? And then there's an even bigger question. If understanding isn't necessary for intelligence, what does that mean for us? Are we, in some sense, also just rooms full of rules, responding to inputs with outputs based on our programming? Or is there something about human consciousness that goes beyond the rules, a spark that makes us truly alive? The Chinese room doesn't give us easy answers, but it does challenge us to think about what it really means to understand, to be intelligent, and to be conscious. As we move closer to building machines that seem more and more like us, these questions aren't just abstract, they're deeply relevant. Because if we ever build a machine that claims to understand us, we'll need to decide whether to believe it. Maybe, in the end, the Chinese room isn't just a test for machines, it's a test for us. To understand what we truly value in intelligence, and what it really means to be human. Swamp Man. One day, deep in a remote swamp, something impossible happens. A bolt of lightning strikes the water, and by pure chance, it rearranges molecules into the exact configuration of a human being. Not just any human being, but an exact replica of you. Your body, your brain, your memories, your personality. This new being, let's call it Swamp Man, is indistinguishable from you in every way. It wakes up, stretches, and walks out of the swamp. It remembers your favorite songs, your childhood, the people you love. It feels like you, thinks like you, and even believes it is you. But is it really? This is the Swampman thought experiment, a puzzle introduced by the philosopher Donald Davidson in 1987. It's a strange and unsettling scenario that dives straight into some of the deepest questions about identity, consciousness, and meaning. At first glance, Swamp Man seems simple enough to categorize. After all, if it looks like you, acts like you, and thinks like you, then why wouldn't it be you? But as you dig deeper, the story starts to unravel, revealing profound philosophical problems. Let's start with the question of identity. If Swampman has your memories, skills, and habits, does that make it you? Or is there something else that makes a person unique? Something beyond physical matter and memories? Maybe it's your history, the specific experiences that shaped you over time, or the connections you've built with the world around you. Swampman doesn't have any of that. It only thinks it does. Its memories are a perfect copy, but they're not real. They weren't lived. So, is Swampman just an imposter? If you met Swampman, would it feel like meeting yourself? Or would it be a stranger wearing your life as a disguise? Now let's take this further. Imagine Swampman meets your best friend. It recognizes them, smiles, and starts a conversation about shared memories, things it never actually experienced, but remembers in perfect detail. To your friend, there's no difference. They might laugh, tell stories, and never suspect a thing. But what about the deeper meaning behind those moments? Can Swampman truly connect in the same way you did? Or is it just mimicking the bonds you've built? This touches on a crucial question. Is meaning something that emerges from the process of living, or can it be replicated perfectly? If Swampman can act and feel like you, is it experiencing the world, or is it just running a program? This experiment also challenges the idea of consciousness. If Swampman has the same brain structure and neural activity as you, does that mean it's conscious? Or is it just a machine imitating thought? This question hits at the core of what philosophers call the hard problem of consciousness, the mystery of how physical matter creates subjective experience. If Swampman experiences the world like you do, it suggests that consciousness might be purely physical. But if it doesn't, then there might be something intangible, something irreducible about being alive. And what about morality? If Swampman isn't you, is it even a person? If you harmed Swampman, would it be wrong? Does it have rights, feelings, and autonomy? Or is it just an empty shell pretending to be human? Swampman leaves us with more questions than answers. It forces us to confront the limits of how we understand ourselves and others. It challenges the way we think about identity, experience, and connection. If there's one thing this bizarre thought experiment teaches us, it's that being human isn't just about what we are. It's about what we've lived, how we've changed, and the stories we share. Maybe that's the unsettling beauty of the Swampman thought experiment. It doesn't tell us who we are or what makes us real. Instead, it asks us to look deeper, to explore the fragile, intricate web of memory, experience, and consciousness that makes life extraordinary. And it leaves us wondering, if we ever met Swampman, would we even know? Would it? And in the end, does it even matter? Wigner's friend. Imagine this. You're in a lab conducting a classic quantum experiment, say, observing a photon pass through a beam splitter. The photon has a 50-50 chance of being deflected or passing straight through. In quantum mechanics, before you measure it, the photon exists in a superposition, a strange state where it's simultaneously in both paths. But as soon as you measure it, the superposition collapses, and the photon takes one definite path. That's weird enough. But what happens when someone else is observing you? This is the setup for Wigner's friend, a thought experiment proposed by physicist Eugene Wigner in 1961. It pushes the limits of what we think we know about reality, measurement, and consciousness, questioning whether the universe has a single objective reality or if reality itself is subjective. Let's break it down. You're in the lab, observing the photon. For you, the superposition collapses the moment you measure it. You write down the result in your notebook, maybe left path or right path. From your perspective, the photon is no longer in a superposition. But here's the twist. Wigner, your friend, is standing outside the lab, completely unaware of your result. To Wigner, you and the photon are still part of the quantum system. Until he opens the door and asks what you saw, you're in a superposition of having seen left and right. To him, your measurement hasn't happened yet. This creates a paradox. From your point of view, the photon's superposition collapsed when you measured it. But from Wigner's perspective, the superposition hasn't collapsed yet. Both perspectives are correct, but they can't both be true at the same time. Or can they? Wigner's friend exposes a crack in our understanding of quantum mechanics. The theory tells us how to calculate probabilities and make predictions, but it doesn't explain what's really happening when we measure something. Is there one objective reality that everyone shares? Or does reality depend on the observer? This question gets even stranger when we consider consciousness. Wigner believed that consciousness might play a special role in collapsing the wave function, turning quantum possibilities into a single reality. In this view, your conscious observation of the photon is what makes it real. But if that's true, does Wigner's observation of you make you real? Is reality something that requires a chain of conscious observers? Or is it there all along, independent of anyone's mind? Modern experiments have added fuel to the fire. In 2019, researchers conducted a version of Wigner's friend using quantum entanglement, and the results were unsettling. They suggested that two observers could experience different, equally valid realities. This doesn't mean science is wrong. It works incredibly well, but it suggests that reality might not be as simple or singular as we think. There are a few ways to interpret Wigner's friend, none of them comfortable. One possibility is that the universe is fundamentally subjective, with different observers experiencing different realities. Another is the many worlds interpretation, where every possible outcome happens in a separate, branching universe. When you measure the photon, the universe splits. In one branch, you see left, and in another, you see right. Wigner and his friend inhabit different branches of the multiverse. A third option is that the paradox exposes the limits of quantum mechanics. Maybe the theory is incomplete, and a deeper understanding of physics will resolve the apparent contradictions. Or maybe, as some physicists argue, we're asking the wrong questions entirely, trying to impose classical ideas of reality onto a quantum world that doesn't play by our rules. Whatever the answer, Wigner's friend challenges us to rethink what we mean by reality. Is it something we discover through observation, or something we create? Are we participants in a universe that responds to our measurements, or are we just spectators in a vast, indifferent quantum theatre? In the end, Wigner's friend might not give us answers, but it forces us to confront the strangeness of the universe we live in. and the possibility that reality is far more mysterious than we ever imagined. Brain in a vat. You're walking through a quiet park, enjoying the sun, the breeze, the feel of the ground under your feet. Everything seems normal, but what if none of it is real? What if, instead of strolling through a park, you're a brain floating in a vat of nutrient-rich fluid, wired up to a supercomputer, feeding your mind a flawless simulation of reality? Welcome to the brain in a vat thought experiment, one of the most unsettling philosophical puzzles ever conceived. At its core, this thought experiment asks a question: how can you be certain of anything? If your senses can be manipulated so perfectly, what guarantees that the world you perceive is real? The implications are profound, challenging everything we think we know about existence, consciousness, and reality itself. Let's explore this strange and unnerving idea. The brain in a vat scenario is a modern twist on an ancient question. Philosophers like Descartes asked, how can we trust our senses? Descartes imagined an evil demon deceiving us into believing a false reality. In today's version, the demon is replaced by advanced technology, a computer capable of simulating a world so detailed, so convincing that you would never suspect it wasn't real. Your brain would receive all the sensory input it expects, and it would respond just as it does now. The simulation could make you feel the warmth of the sun, hear the rustle of leaves, even experience the passage of time. But if the experience is indistinguishable from reality, how could you prove it isn't real? For all you know, you're living in a simulation right now, a brain in a vat controlled by someone or something else. This idea might sound like science fiction, but it reveals a fundamental problem. Everything we know about the world comes through our senses. Light enters our eyes. Sound waves vibrate our eardrums. Pressure registers on our skin. But what if these signals are just data fed to your brain by a computer? Without a way to step outside your own perception, there's no way to verify what's real and what isn't. Let's take this a step further. If you are a brain in a vat, what about the people around you? Are they also simulations? Or are they other brains in other vats, sharing a digital illusion? How could you tell the difference? And here's the most disturbing thought. If your brain is in a vat, what happened to your body? Did it ever exist at all? The brain in a vat thought experiment also raises questions about free will. If your actions are based on sensory input, and that input is entirely controlled by a computer, are you really making choices? Or are your decisions just programmed responses to artificial stimuli? What does it mean to be you in such a scenario? But let's flip the script. Maybe being a brain in a vat isn't so bad. After all, if the simulation is perfect, you'd never know the difference. You could live a happy, fulfilling life, blissfully unaware of the vat. Is reality itself overrated, as long as you're content? This idea echoes the philosophical concept of hedonistic utilitarianism, the belief that pleasure and happiness are all that matter. If a simulated life feels just as real as a real life, does it matter which one you're living? This leads to another question. What makes something real? Is reality defined by physical existence or by how it's experienced? If your emotions, thoughts, and relationships feel genuine, are they any less meaningful because they happen in a simulation? Perhaps reality is less about what's out there and more about what's in here. The brain in a vat thought experiment doesn't just challenge our understanding of reality, it also confronts the limitations of human knowledge. How can we be certain of anything if our senses and perceptions can be manipulated? It forces us to confront an uncomfortable truth, that our understanding of the world is based on trust, a fragile faith in the reliability of our senses. Ultimately, the brain in a vat is a reminder of how little we know about the nature of existence. Whether or not you're a brain floating in a vat, the questions it raises about reality, perception, and self are worth pondering. Maybe the point isn't to find answers, but to appreciate the complexity and mystery of being alive. even if that life is simulated. So what do you think? Are you living in a real world, or could you be a brain in a vat? And if you are, would it even matter? The next time you walk through a park, breathe the fresh air, or feel the warmth of the sun, take a moment to wonder, what is reality? And how do you know it's real? Infinite library. The infinite library is a place where every book that could ever be written has been written. But this is no ordinary library. It's a thought experiment, a journey into the strange and fascinating world of infinity and possibility. Welcome to the Library of Babel. The infinite library was imagined by the writer Jorge Luis Borges. Picture it, an endless maze of hexagonal rooms, each filled with books. The walls of every room have shelves stacked with volumes, identical in size and shape. But the content of each book is unique. They're filled with every possible combination of letters, spaces, and punctuation marks. Some books are complete gibberish, others contain coherent sentences. And somewhere, there's a book that tells your life story, word for word. The question is, what does this library mean? In Borges' story, the Library of Babel contains every possible book of a certain length. If you define the length of a book as a fixed number of pages and characters per page, the library has every permutation of those characters. It's a mathematical certainty. If you shuffle a deck of letters enough times, eventually you'll produce every combination. That's where things get strange. Most of the books in this library are utter nonsense, pages of random symbols with no meaning. But scattered among the chaos are treasures, books containing the complete works of Shakespeare, accurate histories of civilizations that never existed, every scientific discovery that will ever be made. Somewhere, there's a book that reveals the cure for cancer, and another that contains the ultimate recipe for chocolate cake. But there's also a darker side. For every masterpiece, there are books filled with lies, errors, or harmful ideas. There are false cures, misleading histories, and dangerous philosophies. In an infinite library, you can find any truth, but for every truth, there's also an infinite number of convincing falsehoods. This brings us to the paradox of the infinite library. It contains all knowledge, but it's impossible to find what you're looking for. Imagine walking through its endless halls, picking books at random. How would you ever locate the single book you need among the infinite shelves? Even if you had a map or a guide, how would you trust it? After all, there's another book in the library that contradicts it. The Library of Babel reflects the overwhelming abundance of information in our world today. The internet, in some ways, is its modern equivalent, a vast repository of human knowledge, filled with both truth and misinformation. Finding the right answer in a sea of data can feel as impossible as navigating Borges' library. But there's another perspective. The infinite library is not just a place of confusion, it's also a celebration of possibility. It reminds us that within the chaos, there is beauty and meaning. The sheer scale of the library is a testament to the boundless creativity of the universe. Every idea, every story, every conceivable reality exists somewhere in its endless stacks. And perhaps that's the point. The Library of Babel is not meant to be solved, it's meant to inspire awe. It's a mirror of the infinite potential of human imagination and the vast, mysterious universe we inhabit. It challenges us to embrace uncertainty and to find meaning, even in the midst of chaos. The infinite library is impossible, but it feels strangely familiar. It's the story of humanity's quest for knowledge, a reflection of our greatest hopes and deepest fears. And like all great thought experiments, it leaves us with more questions than answers. How do we navigate infinity? How do we separate truth from fiction? And what does it mean to search for knowledge in a world where anything is possible? Burke's teleportation. Picture stepping into a teleportation machine, a marvel of technology. With a bright flash, it disassembles every atom in your body, converts the data into a signal, and sends it across space. On the other side of the world, or even the galaxy. A perfect copy of you is reassembled, atom by atom. You step out, stretch, and marvel at the efficiency of the future. But wait, is that really you? This is Burke's teleportation paradox, a thought experiment that asks unsettling questions about identity, consciousness, and what it means to be you. It challenges us to consider, are you your body, your mind, or something else entirely? Let's start with the basics. Teleportation, as imagined in this paradox, works by scanning every particle in your body, recording their position and state, and then recreating that exact arrangement somewhere else. Your original body is destroyed in the process. The person who emerges on the other side has all your memories, thoughts, and personality. They feel like you. From their perspective, nothing strange has happened. They remember stepping into the machine and stepping out as if no time had passed. But to an outside observer, it's clear that the original you was annihilated. So here's the problem. If the machine destroys the original, is the person on the other side truly you, or just a copy that thinks they're you? What happens to the consciousness that was you before the machine? Does it transfer, or is it lost forever? This paradox forces us to confront the nature of identity. If the person who steps out of the machine has all your memories and acts exactly like you, are they any less you than the original? After all, every cell in your body is replaced over time, and yet you don't feel like a different person. What makes teleportation any different? One way to think about it is through the lens of continuity. Normally, your body and mind change gradually over time, but teleportation breaks that continuity. It interrupts the physical link between your past self and your future self, creating a gap that's hard to reconcile. Now, let's push the thought experiment further. What if the teleportation machine didn't destroy the original? What if it simply copied you, creating a second version of you somewhere else? Now there are two of you, identical in every way. Both versions believe they're the real you, but they're now living separate lives. Which one is the true you? Or does the concept of a singular you even make sense anymore? This scenario raises profound questions about consciousness. Is your sense of self tied to a specific physical body? Or is it something more abstract, like information or patterns? If it's the latter, then maybe teleportation, or even duplication, doesn't destroy you at all. It simply creates new instances of the same identity. But what if we go even further? Imagine that instead of transporting you instantly, the machine works slowly, replacing your atoms one by one with identical particles. Over time, every part of you is swapped out, but at no point are you fully destroyed. Would you still be the same person? Most people would probably say yes, yet functionally, this is no different from teleportation. It's just a matter of timing. Burke's teleportation paradox forces us to grapple with the fundamental mystery of consciousness. Despite advances in neuroscience, we still don't know why the experience of being you exists at all. If the brain is just a collection of neurons firing in complex patterns, why does that create a first-person perspective? And if consciousness is tied to physical processes, how can we ever be sure it survives teleportation? Some argue that this paradox shows teleportation will never be viable, at least for conscious beings. Others believe it reveals that our understanding of identity is flawed, that you are not a singular, unbroken entity, but a series of overlapping states like frames in a film. Still others take a more unsettling view, that every moment of consciousness is unique, and the you of today is already a different person from the you of yesterday. In the end, Burke's teleportation paradox isn't just about a hypothetical machine. It's about what it means to exist. It forces us to confront the uncomfortable truth that identity, consciousness, and life itself are far more fragile and mysterious than we like to think. And maybe that's the most profound takeaway, that being you, right here, right now, is a fleeting and extraordinary thing. So, Would you step into the teleportation machine knowing what you know now? Would you trust that you will step out on the other side? Or would you hesitate, unsure if what makes you you might be lost in the process? Cheshire Cat Experiment. The Cheshire Cat Experiment sounds like something straight out of a whimsical novel, but it's not about mischievous felines. Instead, it's a quantum thought experiment that turns our understanding of reality on its head. It raises a bizarre question. Can an object exist separately from its properties? Let's set the stage. In Lewis Carroll's Alice's Adventures in Wonderland, the Cheshire Cat is famous for its mischievous grin that lingers even after its body disappears. The grin and the cat seem to separate, defying common sense. This odd imagery inspired physicists to explore whether something similar might happen in the quantum world, where sense and logic are often twisted into unrecognizable shapes. In 2014, scientists took this idea and turned it into a real experiment. They used a neutron, a tiny subatomic particle, and its magnetic moment, which acts like a quantum compass needle, pointing in a specific direction. The key question was, could the neutron and its magnetic moment, its grin, be separated in a quantum system? The experiment relied on a quantum phenomenon called the quantum Cheshire Cat effect. Here's the idea. In quantum mechanics, particles don't have fixed locations. Instead, they exist as probabilities, spread out over space until they are observed. This makes it possible to separate a particle from one of its measurable properties. Using a neutron interferometer, a device that splits and recombines particles, the researchers sent neutrons through a crystal that divided their paths into two separate routes. One route carried the neutron itself, while the other carried its magnetic moment. When the paths were recombined and analyzed, the results were shocking. It appeared that the neutron traveled along one path, while its magnetic moment took the other. In other words, the cat and its grin had split. So what's going on? In classical physics, objects and their properties are inseparable. A ball has its position, color, and speed all in one package. But in the quantum world, things aren't so straightforward. A particle's properties, like its spin, charge, or magnetic moment, can exist in different locations, defying our everyday logic. This bizarre behavior comes from the mathematical rules of quantum mechanics, which describe particles not as discrete points, but as waves of probability. When you measure a particle's property, you collapse its wave function, forcing it to choose a single outcome. But until then, properties can behave independently, as though they are detachable from the particle itself. The implications are mind-bending. The Cheshire Cat experiment shows us that the quantum world doesn't care about our intuitive understanding of reality. It forces us to ask uncomfortable questions. What is a particle? Can it exist without its properties? And if particles can split from their properties, what does this mean for objects we think of as solid and indivisible? One interpretation is that the experiment reveals a fundamental strangeness of quantum systems, that properties are not intrinsic but relational. They only exist in the context of measurements and interactions. Another possibility is that this behavior hints at deeper layers of physics, layers we have yet to uncover. At its core, the Cheshire Cat experiment is a playful yet profound reminder of how little we truly understand about the universe. It challenges us to think beyond our everyday experiences and embrace the weirdness of quantum mechanics. Much like the Cheshire Cat in Alice in Wonderland, the quantum world is smiling at us, daring us to figure out its secrets. In the end, we're left with more questions than answers. But isn't that the beauty of science? It's not about finding all the answers. It's about the journey, the wonder, and the moments when reality feels as strange and magical as a storybook. Information hazards. The universe thrives on discovery. From the smallest particle to the vast reaches of space, humanity's relentless curiosity has unlocked countless secrets. Knowledge has been our greatest tool, propelling us forward, solving problems, and building civilizations. But not all knowledge is harmless. Some information, by its very nature, can be dangerous. These are called information hazards, and they challenge our belief that more knowledge is always better. An information hazard is a piece of knowledge that poses a risk simply by being known. Unlike physical dangers, like a wildfire or an earthquake, the harm doesn't come from something tangible. Instead, it emerges from the way the information interacts with minds, technology, or society. The most unsettling part: some information hazards could have consequences on a global scale. Let's consider a simple example. Imagine learning the exact location of a hidden door to a bank vault. The knowledge itself might seem harmless to you, but in the wrong hands, it could lead to chaos. Now scale that up to something like discovering how to engineer a deadly pathogen or how to disable critical infrastructure. The information itself isn't dangerous in isolation, but it becomes hazardous when it influences the world in unintended or malicious ways. The problem is not just the knowledge itself, but how it spreads. Information is like a virus. Once shared, it's nearly impossible to contain. The more people know, the harder it is to predict the consequences. This becomes particularly concerning in the age of the internet, where a single leak can reach billions of people in seconds. A chilling type of information hazard is something called a decision hazard. This occurs when knowing something influences your behavior in harmful ways. For example, imagine you learn that a certain disaster is highly likely to happen in the next 10 years. That knowledge could lead to panic, societal breakdown, or even self-fulfilling prophecies, where people's reactions make the disaster more likely. One infamous thought experiment in this realm is Rocco's basilisk. The idea is that a future artificial intelligence might punish anyone who didn't help bring it into existence. Even considering the possibility creates a strange mental trap. If the AI becomes real, would you regret not acting sooner? While it's just a thought experiment, it highlights how certain ideas can twist our decision-making in unsettling ways. Then there's the existential threat of technological information hazards. Imagine if someone discovered the blueprint for a doomsday device, a machine capable of ending all life. Even if that knowledge was locked away, it could eventually fall into the wrong hands or inspire someone to build it. The mere existence of such knowledge is a risk we might not be equipped to manage. So, how do we deal with information hazards? Can we control what we learn or share? History suggests that suppression is nearly impossible. When people are curious, they dig. And when something is hidden, it often becomes even more desirable to uncover. Instead of suppressing knowledge, some argue that we need to focus on managing its spread and creating safeguards to mitigate potential harm. The challenge is walking the fine line between curiosity and caution. Humanity has always thrived by pushing boundaries, but we're now venturing into territories where a single idea could have catastrophic consequences. Information hazards remind us that knowledge is not inherently good or bad. It's the context and the way we wield it that matters. In the end, perhaps the best safeguard is awareness. Understanding the potential risks of certain types of information can help us approach discovery with responsibility and humility. Because while the universe is full of secrets waiting to be uncovered, not every truth is one we're ready to face. The doppelganger universe. And imagine you're walking down a crowded street. Suddenly you stop dead in your tracks. Across the way, you see someone who looks exactly like you. Not just similar, identical. The same eyes, hair, posture, even the way they hold their phone. It's as if a perfect copy of you exists in the world. Is this a case of mistaken identity? Or could it be evidence of something far stranger? This is the idea of the doppelganger universe, a mind-bending thought experiment rooted in the concept of infinity. It takes us on a journey into the vastness of the cosmos, challenging everything we think we know about reality, identity, and existence. To start, let's talk about how staggeringly huge the universe is. Our observable universe spans 93 billion light-years, with trillions of galaxies, each holding billions of stars and even more planets. It's impossible to truly comprehend how vast this is. But here's the catch. The observable universe might be only a tiny bubble in an even larger, possibly infinite cosmos. If the universe is infinite, strange things become not just possible, but inevitable. Imagine rolling a pair of dice. In a finite universe, you might roll every combination of numbers eventually. But in an infinite universe, you'll roll the same combinations over and over again. Now, scale that up to reality. If there's infinite space filled with stars, planets, and people, it's only a matter of time before the particles in the universe arrange themselves into something identical to you. This is where the doppelganger universe comes in. Somewhere out there, in the endless vastness of infinity, there could be another version of you. Maybe they're sitting in a room just like this one, listening to these same words. Or maybe their life is just slightly different. Maybe they chose a different career, live in a different city, or wear their hair a little differently. And for every variation, there could be countless more. This isn't just science fiction. It's a possibility born from real physics. The idea is rooted in the theory of eternal inflation, which suggests that the universe we see is part of a much larger multiverse. In this framework, new universes are constantly being born, like bubbles in a boiling pot of water. Each bubble might have different laws of physics, but some could be almost identical to ours. And in those, there could be other Earths, other versions of you, living out alternate lives. But the idea of doppelgangers raises some unsettling questions. If there's another you out there, what does that mean for your uniqueness? Does your existence lose meaning if it's just one of countless copies? And if your double made different choices, would their life be better or worse than yours? It also makes us question the nature of identity. Are you defined by the unique path you've taken through life, or by something deeper, something that no copy could ever replicate? And if you met your doppelganger, would they feel like a stranger or like looking into a mirror? But let's zoom out even further. The doppelganger universe isn't just about individuals, it's about everything. In an infinite cosmos, every possible arrangement of matter could exist somewhere. There could be worlds where history played out differently, where life evolved in ways we can't imagine, where the very laws of physics are unrecognizable. Infinity isn't just big, it's weird. Of course, this is all highly speculative. We don't know for sure if the universe is infinite or if doppelgangers are even possible. Our current understanding of the cosmos has limits, and the answers to these questions might remain forever out of reach. But even as a thought experiment, the doppelganger universe challenges us to think differently about existence. It forces us to confront the vastness of reality and the tiny, fleeting nature of our place within it. Yet it also reminds us that even if there are infinite versions of you out there, none of them are living this exact moment. Right here, right now, you're the only you that matters. So, what if there's another you in the infinite expanse of the cosmos? What if they're wondering the exact same thing right now? Maybe that's the beauty of the doppelganger universe. Not that it diminishes who we are, but that it shows just how extraordinary it is to be this version of you, living this life, in this corner of the universe. Temporal reversal. There is nothing that prevents time from moving in a backward direction. Imagine a world where a broken clock winds itself back together, or a demolished building rises piece by piece to its original form. It sounds like fiction, but deep within the laws of physics, this idea isn't as absurd as it seems. Let's start with how we usually think about time. In our everyday lives, time moves in one direction, forward. We call this the arrow of time. It's why we age, why memories form, and why cause always seems to precede effect. But here's the strange part. The fundamental laws of physics don't actually require time to flow this way. The equations that govern the universe work just as well if time runs forward or backward. Take Newton's laws of motion. If you watch a video of planets orbiting the sun and play it in reverse, the motion still follows the same rules. Even quantum mechanics, the spooky world of particles, doesn't inherently prefer one direction of time over another. So why, in our everyday experience, does time seem so stubbornly one way? The answer lies in entropy. In simple terms, entropy measures disorder. Think of it like this. A tidy room has low entropy, while a messy room has high entropy. The second law of thermodynamics tells us that, over time, entropy tends to increase. Eggs break, not unbreak. Ice melts into water, not the other way around. This increase in entropy creates the illusion of time flowing forward. But here's where temporal reversal gets really fascinating. What if entropy didn't always increase? What if there were regions of the universe or moments in time where entropy decreased? In such a scenario, time could effectively flow backward, at least from the perspective of those within it. Imagine a world where people remember the future but not the past, where cause and effect swap places. This isn't just idle speculation. Physicists have explored scenarios where temporal reversal might occur. One idea comes from black holes. At the center of a black hole, the laws of physics break down. Some theories suggest that the extreme conditions could create pockets of reversed time. Another idea involves the early universe. Right after the Big Bang, when the cosmos was in an incredibly low entropy state, it's possible that time flowed differently, or even symmetrically, in both directions. But if temporal reversal is possible, why don't we see it? The truth is, we might not be able to recognize it, even if it's happening. If your entire experience of time were reversed, you wouldn't know the difference. To you, the reversed flow would feel normal, just as forward time does to us. This raises unsettling questions. Is our perception of time just a cosmic accident? Could there be civilizations or beings in some distant corner of the universe living in reverse? Their futures, our pasts. And if we ever encountered them, would communication even be possible? Temporal reversal challenges us to rethink our most basic assumptions about reality. Time feels like a constant, unshakable march, but the universe may be far stranger than we imagine. It invites us to question not just the nature of time, but our place within it. As we explore this idea further, one thing becomes clear. Time is not as straightforward as it seems. Whether it flows forward, backward, or even in ways we can't yet comprehend, it remains one of the deepest mysteries of the universe. And as long as there are mysteries, there will be questions to ask and answers to seek. Maybe that's the true direction of time, not forward or backward, but toward understanding.